Hi, Himanshu, are you there? Let's wait for some others to join, then we will start. Or is it the case like just only one person is joining, then we can start from now. Yeah. So I want to know about you, Himanshu, if you have joined only. What's your background and why you are studying this course? Any introduction from your side? I wait for that. Okay, so I just introduce about myself. I'm Yash. I'm a PhD student at IIT Delhi, and I'm your tutor in this course. And so this course is about, let me share the screen. Let me do that. Yeah. Yeah, so if you can see the screen here. Hi, Sugandhi. Okay, so yeah, I'm your tutor, and the course title is this, Mathematical Modeling and Simulation of Chemical Engineering Processes. So I'm from mathematics background that you should know, and I'm still like enjoying this, like how we model this using mathematics. But I'm working in mathematical biology, so similar related areas and all. So yeah, Professor Saurav has already explained in your first week sometimes like some basic things about what you need to focus on. So I just write sometimes here. Okay. Yeah, so we will start with like how do we do mathematical modeling? So first question is this. How to make oh, okay. I just start with some other things. How to make a mathematical model and how does it look like based on what? So what are the steps to make a mathematical model given you have a real data or given you have some kind of a real world process, whether it's chemical engineering process, whether it's biological process in general, any type of process. So how do you make use of mathematics into that? So that's one part of this course. So I just start with that. So you have to start and you have to set assumptions for the model. Okay, start means, so you start with some kind of phenomena. Phenomena is like, you see that, for example, the population is growing, or some kind of a virus that is growing and infecting people, like these types of phenomena. So you observe a particular type of phenomena and then set assumptions for the model. What are the assumptions you can take? It's like we just consider the population size in a small city, not in the whole world, like these kind of assumptions. So you provide some assumptions before you set up your model. So you start with the phenomena, then you set some assumptions in your model, then in a very basic terms I'm saying, and then develop an equation framework. That is very important. Okay, so you start with something well-known phenomena. You make some assumptions and then you develop an equation framework. It means that can you describe that phenomena using sort of differential equations, partial differential equations. So in this course, we are mainly focusing on differential equations. So no need to worry about other mathematical tools. Let me add others who are joining. And it will be very helpful if you guys can introduce to me and what are your expectations in this course and what is your background, so I can assist you with that. Hi, Shrikant. Okay. Okay, so when we have developed an equation framework, it means a set of ordinary differential equations coupled or just a single differential equation with some initial conditions. Then you need to simulate because, like if you have a complex kind of differential equation, so if you have this one, then you can easily solve it like you can find the exact solution easily. But if you have a complex kind of differential equation like this one, d2e by dt2 c maybe uh, under root v or some kind of sine v or something like this, maybe you will not be able to find because it's non-homogeneous and more complicated. So in order to solve this equation, then you need some numerical methods. So numerical methods to solve such equations. Okay. And then, so once you have like, you are solving such equation using a numerical method. Then, okay, so you have how the real population grows like. So P is the population and it grows like this over time. So this is the real world application. Then you have some kind of simulation or the solution of this equation, which fits like this, and this is your simulated data. Sorry, not the data, but the simulated solution. And this is the real world. So how do you compare your real world solution, real world data with the simulated solution? So what is like, how do you compare the difference between the two? So next step is similar like this. So you have to simulate it numerically, and you need to be sure that your numerical method is correct. That is also important. And so you find how accurate real world data fits, how accurate real world data fits the exact or simulated solution, right? So if it fits exactly, then it's well done. So if it fits good, then it's yes, your model is approved. And if it does not fit nicely, then no, then you have to Sorry, in this case. Then in this case, you have to lose your assumptions. Lose your assumptions. Okay? Lose your assumptions and make changes in your model. In the model so that it fits well. It fits well and it represents the real situation well. That's the direct comparisons. And that's all. That's about the mathematical modeling part. But how do you model the chemical processes? That is one question. So he has given some introductory tools to study, but we will do some kind of introductory session. So first week is about the introductory session with the professor. And we will look at some questions now. Looking into some questions. Yeah. So you know what is mathematical model and how you can frame it now. Um, but it's hard, it's not easy. You need to understand the process very well. You need to understand what's going on. And to capture that, we will just start. So I will just present some basic examples first and then basic examples like how to model. Okay, let's start with that. So you have, suppose, I just use a different color, maybe red. Suppose you have a tank. There is a tank of volume V, okay? V is the volume. Yes. And there is inlet stream with flow rate F and concentration C. So you kind of have water coming into the tank with concentration Ca in and with flow rate F. It is flowing with the rate F. So I just use C in. And then it is going out with the flow rate F and concentration C. So F the same rate, which is going out, and the concentration C. So how do you model this situation when water is coming in the tank and going outside with some flow rate? So the change in the concentration of the water, change in the concentration is directly proportional to C in minus C, maybe. Yeah, I just model the C out. So how does the concentration outside is changing? That is directly proportional to the difference between initial concentration and our outside concentration and multiplied by some. Yeah, so here we multiply V because we are considering whole tank volume. So we multiply by V and it is directly proportional to this. And this constant is F because, so I just use DC out is same as F times C in minus C out. So that's what I said. So in the mathematical model, you start with some phenomena, you set some assumptions like with some flow rate, or you just have a closed tank, and then you just came out with some sort of equation. So coming to this part is very tricky. So to this part, it's hard, but after that, it may be easier to solve. But it depends. So this is the simple model you can observe. So once you have a ordinary differential equation, you can solve it using exact solution. I think it can be solvable. So if initial concentration is C naught, then you can solve the first. Then CT is given, C out T is given as C in plus CA, C naught minus C in. to the power minus F by Vt. Yeah. So you can find the exact solution and you can really match it to the real world application or whatever, but it's more general. Okay. So after that, I will give some, because it's just the basic introduction questions on like how you make models. Then we have some, we will see like mathematical tools. So in the second week itself, we will start seeing mathematical tools like how to solve these using Laplace transforms and all. That will come later. Okay. Okay, so let's start with species. In the first week, they started with species transport equation. The species transport equation was this. U gradient C is del times gradient square C. So what does it say? It says how the concentration of a particular species A changes in space and time. So how does the concentration is changing of a particular species is changing in space and time? So this particular equation models this. And if you see here, then there are two types of effects. So this is the change in concentration over time. This is U gradient C is the species transported by bulk fluid. So let's write species transported by fluid. And this change, this is basically the species spread out from high to low concentration. So it's kind of diffusivity constant T with species spread from high to low concentrations. So, so in this, we will do some one question over this and how to prove, how to make use of this equation. Okay. So question one is I write a dilute species A. Okay, I just write with some another pen because it would be so confusing. Okay. So a dilute species A diffuses in fluid along x direction in a slab of thickness L equal 1 centimeter. Concentration at x equals 0 is C0, which is 2 mol per meter cube. And at x equal L is 0 basically. So a first order homogeneous reaction consumes A at rate RA, which is basically minus K times CA, with K is 0.1 second inverse and D is 2 into 10 to the power minus 9 meters squared per second. So write a species transform equation for steady state. You know what steady state means, and find the value of find C. Okay, so just try this and using the same logic, but you need to modify such equation in a way that it comes better. Like, okay, just use it. Yes, okay. Just try this. Just give 5 to 8 minutes and find the value of CA. Let me know what's your answer on this. I will be happy to discuss what is being done in lecture, and I would be happy to discuss that as well. So if you want to discuss that as well, just let me know. We can discuss together. But you just try this question now. Okay, so if you have done this, I think let's go there. Yeah. So what does it say? So dilate species A diffuses in fluid along x direction in the slab of thickness L. Concentration at x equals 0 is given. So these are basically, these things are, I just use the maybe purple. Yes. So these things are your boundary conditions, or called as initial conditions in this case. Yeah. And you are given RA. So this is very important. So homogeneous reaction can consume A at rate, consume at, so RA is minus KCA. So the concentration change is affected by this quantity. So we have a species reaction equation that is basically del C over del T plus mu gradient C equals to D gradient square C. Okay, so we know this only, and we do have, since we have to find a steady state equation, so steady state, we have del C over del T 0 mainly, and we don't have this u in this, so we assume u equals 0. Okay, so we just have only this information, so we will just go with this, then D gradient square C, but we do have to add some another term to make it 0. That is this thing. So it is consumed at rate this, so minus K times C. So the steady state equation becomes T gradient square C minus K times C equals to 0. So that is, maybe just, yeah, so we are considering only, and next question is find C. How to find C? So this is basically your, we are considering one dimension, and it is just this minus K times C equals to 0. Okay. So how do you solve it? It's just a math part. So if you go there, then it is, I just write minus A over D divided by D. And then this is a second order homogeneous differential equation. And you can find the characteristic polynomial, the characteristic root. It is R square minus K by D. So you take this thing over here and R squared for this. And this is 0. You put this as equation, not polynomial now. Then you find out what is R. R is under root K over D. So that is, so R is under root K over D, and the solution would be C is A e to the power RT, Rx in this case, and B e to the power minus Rx. So that's the concentration, which is dependent on x, because we are considering only steady state solution. So change in with respect to time is 0. So Cx it is then. And how to find these A and B? How to find A and B? Any ideas? So we are using the initial conditions. So what are the initial conditions? You have at x equals 0, you have C0, which is 2. Right? So you substitute here in this equation. So C0 is A plus B, which is 2. And at x equals to L, we have C, L is to be 0. So you have A e to the power minus RL plus B e to the power, sorry, it is minus RL equals to 0. and exponential function is just okay, so exponential function is positive, so you can divide by exponential function, and you get minus RL minus RL minus 2RL, something like this, to be 0. And B is just A minus 2 minus A, so A plus 2 minus A, 2RL equals to 0. Then you can find out your A. How do you do that in this case? Let's see. So here you get, okay. So e to the power minus 2 RL is minus A divided by 2 minus A. So it is just A divided by A minus 2 and e to the power minus 2 RL. And so you can take log of something like this and minus 2 RL. Or you can find out, so you can find out this, I think, find A from this. And once you got A, then you will get, then use A plus B equals to 2 to find B. I hope it's clear to everyone. Okay. So in this way, the maths comes like you need to solve the equations, and but main part is to come up with this equation and how to solve it. That's important. Okay, so let's go with another question. Yeah, so one thing I want to mention is like how to dimensionalize, how to redimensionalize and all. So if you have a given, so I just use the reticular, given the partial differential equation. So you have this partial differential equation, del C over del T, D times del 2C by del X squared. C is CXT and all. So how to dimensionalize this? So suppose theta is given as T times T by L square, X is capital X is small x by L, and psi is just C minus C naught divided by CS minus C naught, something like this. Then how to change this equation? Modify this equation, modify one. Terms of psi, theta, and x. So I want, then it's called as uh, non-dimensionalization actually, non-dimensionalization. So just transform this 3D into this type, then it is non-dimensionalization, and just give a couple of minutes. You have to use theta this, at capital X this, and psi as this. Okay, just find it and let me know the answer of this, because it's been discussed in your lectures as well, how to dimensionalize. Okay. Okay, let's solve it. How to non-dimensionalize it. Let's have another one. Okay, so you have this equation del c by del t is t times del to c by del x square. So it's kind of diffusion, and that is change in concentration with respect to time. Okay, so what we have to use theta to be t times d by L square, capital X equals small x by L, psi equals to c minus c naught by cs minus c naught. Okay, so we can just write del over del t as del theta. Okay, let me rub it. Del theta over del t, del by del theta. We can write this. So we just added this quantity del theta over here and there. Okay. And since theta is just dt divided by L squared, so del theta over del t is just t divided by L squared. That is just the classical differentiation of theta. And thus del c over del t is, what is del c over del t? Is cs minus c. So we just substitute. Okay, psi is this. Let me see. So here we are getting something different. Okay, let me try to see. Okay, so I just go normally. So you can find the c from there. So c minus c naught is cs minus c naught times psi, right? And del c over del theta is just del psi over del theta. And if you do and cs minus c naught. And if you multiply del theta over del t both sides, del over del t both sides, del over del t both sides, maybe, or del theta over del t both sides. In that case, let me see. But you have written del over del t as del theta over del t, and del over del theta. Okay. So, okay, so del over del theta is just, let me see, okay. So you get after this, let me add another page. So after solving this, you get something like this, del c divided del t, cs minus c naught divided by 1 t by L square del psi over del theta. Okay. And space derivative I'm talking about. So del by del x can be written as del capital X by del x, del by del capital X, which is 1 divided by L, del by del x. Because it is given that capital X is just x by L, so differentiation gives you 1 by L. So you have changed your small x variable in terms of capital X variable, and how to change this. So similarly, you can find out that del 2 over del c square is just c naught 1 by L square del 2 psi by del x square. So ultimately, you will get something like this. By substituting these on both sides, you will have this psi by del theta, which is same as t times cs minus c naught 1 by L square del 2 psi by del x square. Okay. So you cancel Cs minus C naught and T and L square. Then you get del psi by del theta is del 2 psi by del x square. So that is in terms of psi, theta, and x. Okay, so if you go in your first lecture, then uh, the professor also introduces this non-dimensionalization. Just go with that and try to non-dimensionalize other equations and try to know the meaning of the scaling factors as well. So here I'm not telling that. Yeah. All right. So let me give you one problem where you will have to find out the solution of that. Means how you model such situation. That is okay. So how to find the model equation using the situation I give to you. Okay, let me do that. Okay, I will give you just simple equation. So is it like this? Some make model equation using this information. So you do have a flat catalyst slab of thickness 2L is exposed to gas reactant A. Okay, then the species A diffuses into slab. So it diffuses into slab and undergoes a first order irreversible reaction. Irreversible reaction A to B. Diffusion is 1D along X, symmetric at center, one-dimensional. Just write this. And yeah, so what kind of thing you feel from here? And so diffusivity coefficient is D and it is constant. And you can make more assumptions based on that. But from this information, try to write an equation that governs this. Okay. So make a kind of, I want the concentration of this species over how the concentration is changing. So I want that. Yeah. So just make this, just try this. Okay, so by looking at the information, it's very clear that this is just the species reaction equation. I just use the black reaction equation, but here there is only two parts. So del C over del T, which is just T times del 2C by del X squared minus, if you have some reaction term. So that is reaction term over there. Okay, diffusivity. So you can just write it like that and depends on this. Okay, so what we're gonna do next is, okay, so we learned today what we learned. So firstly, we learned how to set up a mathematical, okay, let me erase steps in mathematical modeling of different, of any process in general. Second thing we learned about how do we model, how do we model certain types of phenomena. Once we have mathematical equation, how we solve it and find exact solutions. And fourth thing we have learned is how to non-dimensionalize the model equation. So these are the steps we followed and to make a good mathematical model. So I just go with the second. So week 2 will be based on, so in the next lecture, we will be focusing on solutions of PDEs by different methods. Hope it's clear. So any questions now? Um, yeah. So if you have any questions, you can discuss with me.
Hi, Yash.
Hi, Himansh. Yeah, nice to meet you.
Actually, we have got some assignments, so just we want to discuss that assignment with you also.
Okay. Is this the week 1 assignment you have?
Yeah. Week one assignment.
Actually, I don't have the previous year assignments, no question papers and all, so I really need. So if you can share that. Um,
Actually, I don't think it can be shared because this has
okay.
been given
But you have assignment questions. Do you have
yeah, I
questions?
have assignment. Yeah.
Means from next time I can make some questions related to assignment as well, like would be helpful for you all. I think so.
Yeah, actually, I have solved it, but actually the problem is that in the assignment we have to write the exact answer. If suppose it
You
was
don't have
means
multiple choice questions?
yeah. We don't have multiple choice question. That is the
Oh,
problem. So the
okay.
answer I got, is it correct or not? That has
Uh,
to be verified first, I think.
okay.
That's why
Okay.
I
But
think
I
it has
don't
to
have
be
any
discussed.
question. Yeah. I don't have any assignment questions in the course. I don't have access.
Mm-hmm.
Mm. But which concept it's like how the questions are, they very easy or difficult,
It is easy only. No, it is easy only. Not that much difficult.
or are
But
they
if suppose
related to
we have
what
got
I'm?
multiple, if
Yeah.
suppose we have got multiple choices, then there was no problem. But we have to write the exact answers. That is just I want to make sure that
Is it is the questions from the lecture notes?
the we have solved and the answer that I got is correct.
Okay. So the questions are from the lecture itself?
Miss Miss topic is that one only, but Miss
Means
you
it's
may
easy to understand
cover
and
different.
relate. Okay. Because I don't know which type of questions are
Sorry.
in your assignment. Um, is it like what I have discussed? Is it helpful for you? Can you hear me?
Hello.
What I have discussed today, is it helpful for you
Actually,
guys?
your voice.
My voice is
Yeah,
not
it is.
coming. Okay, I'm saying
Yeah.
like what
Now
I
your
have,
voice is.
whatever I've discussed today, was it helpful or I just improved more?
No, that is helpful. Surely that is helpful. But
Oh.
just my concern is the assignment that we have got. Means I want that assignment has to be solved from my side correctly. So in order
If you
to
have done true, yeah, if you have done correctly from your side, I think there should not be a problem in, yeah, I think so. Means there will be a manual check and he has given some answers. So depends on the professor, like what type of answers he put in the box.
So, Miss, actually, Miss, the mail that we have got for the discussion today, that assignment will be discussed. So, I thought maybe, suppose we will discuss those questions from my side also, whatever the inputs I can give, then it will be fruitful
Really
for me.
want to discuss the assignments, but once after your assignment submission, no?
Okay.
Like maybe the answers after the assignment submission, but I don't have access. I will write to NPTEL team to give me access to assignments so that I can see which type of questions you are doing and all. And I will do the similar questions here as well, so it won't be a problem. Next, I think.
Okay.
Yeah.
So, next week again, we have same session.
Next week, yeah, at the same time and same day, we have the same session, but more mathematical, I think.
Okay.
Mm.
So, that time means just try, suppose you get access to the assignment so that we can
Yeah, I will write
discuss.
to NPTEL. Yeah, yeah. Otherwise, can I write my email ID if you want to have any doubts, or you can just email me. I will try to solve. Um, you can see
Yeah.
my email ID in the chat. So you can just email me the question you want to discuss. I will be helpful to.
Uh, okay. So where will I get the emails? Your ID?
Yeah, I just writing.
Yeah.
Can you see the chat box? Can you see the email ID I've written in the chat box?
Mm,
No? Oh, yes.
no, suppose you could write on the
Yeah, I
paper
just
that
went.
we are, that it will be helpful.
Just email here.
yashvats425@gmail.com, right?
Yeah, yeah.
Okay, so actually, Miss, our first assignment submission is due on 6th August.
Okay.
So, so we will have time. If suppose by next Tuesday,
Next session
if you
will
get,
be on 5, right?
yeah.
When is okay. So you have time, yes.
So yeah, so every Tuesday we will have the session, right?
Yeah, yeah.
So if suppose by that time you get the access, then it will be better. Actually,
Yeah, that
the
then I will discuss that for sure. Yeah, surely. But not
and
exactly. I
actually,
cannot discuss exact same questions, but if I get access, I will create some different question and try to relate it with yours. I cannot solve exact question because it's like cheating.
Mhm.
And yeah,
It will be
yeah.
fine. No,
So
actually, main problem is that I have solved it. Means if suppose you want, then I
I can
can
give you an
give my
idea,
solution.
like somehow how to approach, but not like
Yes.
exactly. Yeah,
Yeah, means in that case, I can just give my solutions and just you can go through once that is it okay or any modification is required.
yeah, that can be done. Yeah, yeah, okay.
Okay, then I will come
Yeah,
to you contact with that Gmail address.
yeah, sure, yeah, sure. And
Okay,
Sugandhi,
thank
do you have any issues and any suggestions?
Nothing, sir.
Okay, okay. So if no more, then I just close it. But from next time, I think it will be longer. Yeah.
you. Okay,
Okay.
thank
So
you.
no questions. Yeah. See ya. And just finish your assignment by the time, and we can discuss it next week. See you. Bye.
Okay, thank you. Bye.